Welcome to video 9 in a series of introductory videos for the InventorCAM CNC programming software. This video's topic is 3D iMachining. So this will actually be the three-dimensional version of the iMachining toolpath you saw in video 8. There's a few differences, but a lot of it is still the same sort of setup you saw in video 8. So a lot of the stuff I'm going to skip over in this video, you can review in video 8. And that basically is the setup of the part for iMachining, such as the iMachining data, and a lot of the stuff that you saw in video 3 is also skipped in this video. So let's go and add a 3D iMachining toolpath. I'm going to right-click on Setup, Add Milling Operation, 3D iMachining. Now I want to do this on the back side of this part, so I'm just going to switch this to Mac to position 1. And we'll start with the geometry. Now in 3D iMachining, as a recognition toolpath, it's one of the first ones that you'll see in this series of videos. We actually start with the target as the geometry. So I don't actually have to choose anything to set up this toolpath. It automatically recognizes the target as my solid geometry. That isn't to say that you can't just choose on new geometry and then choose whatever solid's on screen. It's just that by default, it goes right to the target. Working area, I'm going to cover at the very end of this video. And everything else here is if you needed to make any certain changes to your geometry. Now, one of the things of note is this new feature here in 2016 called Feature Collision Protection. This actually will recognize any fixture that you've selected on your screen and actually do collision detections against that solid. I don't have any on the screen right here, so I'm just going to uncheck that box. Under Tool, we choose tools the same way we would have seen previously. So I'll start with the 1/2" end mill. Because I've defined this end mill to have a holder, I can do holder collision protection against that. So I'm just going to put in here that it takes the holder within 10 thou of the updated stock or the target itself. Next is levels. Now this differs from some of the other toolpaths in this series in that this is not how far into the part we're going to machine, but how much of the target we are looking at, how much of the target we want to machine from the stock. So I'm going to start from the upper level. We'll just choose that point right there. And the lower level will be the bottom of the part. Now the reason I'm doing top and bottom of the part is because, again, it's just how much of the target I'd like to machine. It won't actually go through the solid. It won't cause any crashes or anything. It's just going to machine all of the target from those between those two faces. Technology Wizard, much as we've seen in video 8, is just controlling the feeds and speeds based off of my machining level selection. So I'll just put that up all the way to level 8. Under Technology, similar to what we did before, we'll leave some material on the walls and the floor, and you'll see in the bottom left corner that that's what those values indicate. Now different here, because this is 3D version of iMachining, is the scallop height. This is how much we're going to leave behind on any kind of tapered faces or curved faces. In this case, I want to rough this out very uniformly. I want to make this look very nicely roughed out so I can go right into finishing. So I'm actually going to make this value the same as my wall offset, my floor offset. So let's do a save and calculate on that. Now it does seem like it takes a little longer to calculate. That's only because it's slicing up that target in the proper Z levels to see how much of it can machine in one go. Essentially what this toolpath will look like is 2D iMachinings on a Z level basis. So it'll start out from the deepest part of the part. So in this case, it might do the corners first, and then it'll work its way along any kind of tapers or curvature. So as soon as this is generated, we'll take a look at that. Okay, so the toolpath began by machining off the excess on the corners, and then it worked its way up this angled face, and it also did that center pocket there again. So again, it's checking the target against the stock to see what material can be removed with this 1/2" end mill. And there's our scallop taking place on the side there. Now, I'm going to open this back up, do a save and copy. Much as you've seen in video 5 or video 8, we have a rest operation function of iMachining. Now, in this case, for 3D iMachining, it's actually much easier to use than you would have seen in the 2D iMachining or the pocketing toolpath. As soon as I do a save and copy, this is automatically a rest milling operation. As soon as I go to Tool and choose the smaller tool, in this case, the 1/4" end mill, you'll see that again, the machining level wants to be updated because I've changed the parameters it's using for the calculation, in this case, the size of the tool. Technology, I'll leave all this the same. And I don't have to do anything here to tell it that it's a rest operation. As a recognition toolpath, it's going to look at the updated stock and apply iMachining 3D to the updated stock and remove only the excess material. In this case, material that the previous half-inch end mill could not do. So again, it's just doing a little extra calculation there just to get that updated stock. And now using the 1/4-inch end mill, it's going to do whatever's remaining. This will include the internal corners and maybe those slots on the edges. Okay, and if we take a look at that, those internal edges there, and maybe some of the slots. Now, in this case, the slots are probably just large enough that the half-inch could get in there, but you'll see that it recognizes those corners there. Okay, so let's return to the top side of the part, and I'll show you one additional function of 3D iMachining. So let me just open up another 3D iMachining. In this case, we're going to do it on Macklin position 1, so the top side. The target is still my geometry, because I'm still working off of the solid, but because I want to just focus on the inside of the part, I don't want to do anything outside that internal pocket. So that includes all those steps and all those features in there. I'm actually going to add a working area. Now, working area is essentially just a contour geometry or a chain geometry to fence off the area that I like to work on. I'll just engage working area, click on Define, and this chain selection geometry window is the same you would have seen in video 5 or video 8. I'm just going to choose this edge right here. I'll do a constant Z propagation to choose the rest of that edge. And what I'm doing here is I'm basically telling SolidCAM, I just want to machine what's inside of that fenced off area. What's inside of that chain? Now, working areas, it's not just the chain, it's what type of working area it is. And you can see here in this pull-down list, there's actually 4 types: internal, external, center, and tangent. And each one of those is really just how the tool is going to sit inside of this working area, inside of this fenced off area. So we'll start with internal. Internal is telling InventorCAM that I would like the tool to stay completely inside of that contour. It can only reposition inside the contour, and it only machines what it finds of the target inside that contour. External only machines what it finds inside of the contour, but allows it to reposition outside the contour. So that would be less restrictive. It allows it to actually go outside the contour, reposition if it needs to do anything on another side of the part. Between those two, you'll be able to handle all kinds of situations that you would be using 3D iMachining for. There are some instances where you may want to go a little farther outside the contour. Let's say if you wanted to do sort of like an internal, but once it gets to the corner of the contour, it actually leaves a cusp behind. So you want to kind of just go right into that corner, but without leaving the actual working area. That's where you can use center. It actually allows the tool to only machine what's inside of the contour and travel as far outside of the chain as the center of the tool. So it actually allows it to go right to the corner defined by that contour. And then tangent is slightly further than that. It allows it to maintain a tangent point with the working area. Let's go with external for now. So I'll click OK on that. The rest of the programming of this is exactly the same. So I'm just going to go with half-inch end mill. Levels, in this case, again, I can choose anything I want to do the travel here. I'm just going to go right to this pocket here because that's all I can really do anyway. Technology Wizard, put that up to level 8, and Technology. Now, under Link, I skipped it over just because it really just applies to the overall use of iMachining. If you have a non-sensor cutting tool, so let's say it's a non-sensor cutting standard end mill, or it's an indexable or an insert tool, that affects the helical entry used by iMachining. So you'll want to uncheck this box and modify your step down of that helical entry to account for the fact that it's non-sensor cutting. Also, I didn't mention, but if you have any pre-drilled holes or any previous geometries or previous toolpaths before your 3D iMachining, it still recognizes those as well. So it always acts as a rest mill operation. And we'll see that here, because even though I'm doing side 2, the side 1 that I'm working on now recognizes the operations from side 2. So as we saw before, this previous toolpath machined all the way down this hole here. So from this side, it just means I'm not going to have any material in the center there. So if I do a save and calculate on this, we'll see that it recognizes all the material and it's generating a toolpath for just inside of that working area. So because that previous tool did not go all the way through to the very end of the stock, there's still some material that needs to be removed. And you'll see here that it recognized the steps on all 4 sides and the material that needs to be removed here as well. There's different levels there. So 3D iMachining is just a 3-dimensional version of the 2D iMachining toolpath, and it's actually one of the more powerful toolpaths from InventorCAM. Any questions on this or anything else from InventorCAM, you can always call us at 1-866-975-1115, extension 2. You can send us your parts or your questions via the ticket system at solidcamsupport.com, or stay tuned for the rest of the videos in this introductory series. Thanks for watching.